Hello everyone, this is Riksa Awan. I'm an agronomist and I'm also heading outreach department in SAWiE. SAWiE basically is a UK organization. It means it's sustainable agriculture, water and intelligent ecosystem. Now formally we will start this workshop. I hope so it will be very fruitful for everyone. If you want to ask any question, then you can just raise your hand. We will provide you an opportunity to speak in this workshop. Thank you so much. Here we will start our workshop formally. The topic of this workshop is use of GIS mapping for biomass energy assessment. For welcome note and introduction, I would like to request Mr. Dr. Orginirona. Sir, please present welcome note and introduction to everyone. Thank you so much.
Thank you very much. Today's workshop is a follow-up from what we had yesterday. Just before I proceed, let me just give you my full name. I'm Organelwana Diomudeke from University of Port Harcourt. I'm of the Department of Mechanical Engineering, and we'll be working in the area of sustainable energy, particularly solar and biomass energy conversion technology. So the job is actually intended to enhance networking and capacity building between UK and Nigeria working in biomass energy. The workshop are part of our ongoing project in Nigeria, which is on the mapping and development of geographical information system of biomass potential in Sub-Saharan Africa. The project is funded by GCRF, but administered by the Academy of Medical Sciences. So we've had this one sometime 2019 before the COVID-19 setting. This third round of it. So the essence is to synergize and see how we could improve the bioenergy conversion technology in Nigeria by learning the experience of advanced country, especially in the UK. So for today, we'll have a presentation from Mike Ukoba. He's a PhD student in the Department of Mechanical Engineering, and I supervise him. He's working on biomass assessment of Nigeria using GIS. So he will be doing the presentation. He's here. So I think we can start with that. Or do we do a round before we go ahead with the presentation? Riksa.
Okay, thank you so much, Mr. Orginirona. If anyone want to ask any question, then you can ask, so we can proceed our workshop. Is there anyone who want to ask? Okay. The next presenter will be Mike, Engineer Mike. He will speak about biomass energy assessment in Sub-Saharan Africa, a case study of Nigeria. So please welcome Mr. Mike.
Yeah, good morning, everyone. I am Engineer Michael Koba. Let me just, at this point, share my slide. Please someone confirm if you can see my screen.
Yes.
Okay.
Maybe if you can, oh yes, that's good. Thank you.
All right. This presentation is coming to you from the Department of Mechanical Engineering, University of Port Harcourt, Nigeria. I am Engineer Michael Organelremu Koba, a PhD scholar in the said department. I'll be presenting on biomass energy assessment in Sub-Saharan Africa using Nigeria as a case study. Here goes the presentation outline. Take a little introduction. Biomass resource potential in Nigeria, GIS analysis being a tool to analyze the biomass resource potential. And then we'll go over to remote sensing and then conclusion. Energy happens to be the bedrock for modern societal development. The irregular power is actually a major problem in Nigeria as well as other developing nations. Disposal of organic waste through open dumping, burning, and all that has led to exposure of communities to pest and hazard. Next slide. The continuous increase in energy demand as population rises and technology increases, as well as the mitigation of climate alteration has drawn researchers' interest because it's a global vital challenge based on the fact that the conventional form of energy generation, which is fossil fuel, it's not too clean and it's causing a problem even in our environment. So it is important that we tend to dive or we look at getting energy sources that is not only efficient, but also clean. And biomass happens to stand out in this regard. Researches have been carried out. I did a research 2 years ago during my master's program, and we discovered that biomass from the research even supports carbon negative economy if the technology of converting this process is quite okay. Agricultural data from FAO in 2021 shows that food security, energy, as well as other benefits achieved via biomass sources. Biomass sources cannot be
Is this from my end only or?
I think it's about
animal can be obtained from crops, sewage. Okay. Can you hear me, please?
Here you missed me.
We miss you. So maybe you reshare this.
Okay, you can see my slide again.
No.
Oh.
Okay, yes. Go ahead.
Okay. Biomass resources are in many forms. It can be obtained from animal, crop, sewage, and all of that. But we intend to focus here on agricultural biomass, primarily crop and forest residue. The intention is that rather than battling with generating energy from food products, those residues, example, peels, and all that are being burnt or disposed indiscriminately, causing environmental hazard, can be gathered and used for electrical energy generation that the developing nations are combating with. Biomass has great potential and can serve as an alternative source of energy. This source is not just economical, but it is available, it is replenishable, and it is carbon neutral using suitable technology. The figure 1 shows the crop production in Nigeria, the yield and the area harvested in the year 2019. The crop production as it's graduated from is highest for cassava, yam, maize, oil palm fruit, rice, and all and goes down. The second figure at the down shows the ones that have low production, as the case may be. Here we have the forest production or product and production as at 2020. Analysis was carried out and we discovered that the crop residue potential in Nigeria based on the resources available can be obtained as this. We have theoretical energy potential, economic and technical energy potential. Resource, oil palm tree, maize, as well as sorghum, which is also called guinea corn, stands out in Nigeria. These 5 major crops are very vital crops that has high energy potential and can be used, the residues can be used for power generation in Nigeria. Here we have the forest residues and their energy potential after analysis was carried out in the year 2020 in Nigeria. And after all said and done, the energy potential of crop and forest residue about 3,477.02, as well as 685.90 petajoules per year is possible for crop and forest residue respectively. Now let's come to the tool that one can use for the analysis of biomass production, GIS assessments. The first question is, what is GIS? GIS is a computer-based, modern, and still advancing technology that captures data, stores data, analyzes data, and brings out the results in form of charts, in form of map, graph, and in several ways, pictures. So data may be collected Is someone confirm if you hear me?
Yes.
Yes, we can hear you.
Go ahead, please. Mike, are you still there?
Especially in Lagos.
We've lost audio signal.
So data may be okay. Data may.
I think
Mike.
Michael just.
Okay.
Michael, can you?
Sorry, the network is a bit unstable from my end.
It's okay.
Okay, so I guess you can hear me now, please.
Yes, we can hear you.
Okay, so GIS is a framework that primarily collects and analyzes spatial data and then presents the results in different forms.
We can hear you,
Okay.
Mike.
Now, the question is, what is spatial analysis? Because GIS analyzes spatial data. Spatial analysis simply means any techniques that studies the topological, geometrical, and geographical properties of a particular place or a particular object. different types of layers can be integrated into a GIS and presented in a map layer. Examples, we have streets, offices, demographic, topography, and land cover, which is of interest in this particular study. Land cover where we would be getting the vegetations and agricultural data. This helps one gain insight in relevant characteristics of a place. The roles of GIS in the agricultural sector stands out. First, it helps to know how to protect crops. Now, when the imagery is captured, an analysis is made, one would be able to analyze to know the type of pest that was in that land, and then the farmer will know how best to eradicate that pest or to with that environment so as not to be adversely affected by the pest. It analyzes soil data combined with historical farming practice so as to determine the best type of crop to be planted in a particular location. GIS helps farmers achieve increased crop productivity, and so how it also better help us know how to manage land resource. It helps solve crop issues. It also helps to know how to irrigate the land. Knowing the topography of the place, GIS would also assist farmers in that regard. It provides various types of mapping that will be useful for agriculture. Here's a picture of GIS map and analysis for Nigeria. It shows the different crops as it's distributed for the various states in Nigeria. The left of the figure 2 shows that of beans, millets, groundnuts, maize, rice, and guinea corn, while that of the figure at the right shows another. Now, here we can see that one can use GIS to display in form of pie charts as well as bar charts. That is one of the analysis GIS can perform. Here, forest reserve areas by state is also stipulated here. Now, but what we did here, we collected, we cited a certain location per state, and then use it to represent the entire forest in that particular state. Now, there is a little challenge here. It means that the various location is not projected, it's just one. So this problem will be solved by what we call a remote sensing, which will help to stipulate the various places where the forest resides in the different states that we have. Crop residue distribution by state for the 5 major energy potential crop in Nigeria is presented in figure 4. While the crop production of the top energy 5 crops is also presented. Here we'll have the interpolation of cassava production, interpolation of maize production, interpolation of sorghum, which is guinea corn, and that of rice production displayed in figure 6A, 6B, 6C, 6D, and 6E also shows that of oil palm. Now, the interpolation helps us to know the various production of the various points, the various potentials of this crop as you move from where it is highly situated to other regions. Figure 7 shows the GIS interpolation of estimated crop residue, Y8 that of forest land area, and 9 that of forest residue. So GIS also helps us to do or carry out interpolation of data. The figure in figure 10.10, we have the Nigerian biomass distribution across the various states. Now, how is this achieved? It is achieved through the process or the software called remote sensing. So the map is categorized into 6. The area that shows the blue colors gives or stipulates the water body areas. The area that shows red colors stipulates areas that have built up areas, and that of Topex sand shows the barren land. Yellow shows cropland and grassland, while light green shows crop areas, and then finally dense or thick green in the map shows the forest vegetation in Nigeria. Now, how is this map or how is this done? That brings us to the subject called remote sensing. Remote sensing is simply the act as well as science of making measurement about an object environment without necessarily being in physical contact with that environment. Okay. Now, the sensing of our eye is a visible light range of 400 to 700 nanometers. Now, remote sensing instruments uses that's much more that of the human. Okay, this makes the remote sensing and GIS a very powerful tool in recent time. With remote sensing, we can get several images with different wavelengths at the same time. Now, on getting this information, we can then identify the material components of a particular area, and then analysis can be done with this based on cropland, forest, and all that. Now, let's take an instance of a geographical location which crop and forest land has been captured and analyzed in Nigeria, a place, Edo State. We have, by the right of the figure, the map of Nigeria, and the area that is captured shows Edo State map. Okay. Now, NVI image is generated from land satellite image acquired from USGS in the year 2021. That is when I generated this image that I used to do that of Edo State analysis. The expression below was utilized NDVI, the surface reflection value for near infrared minus the surface reflection value for the red spectral band, all over surface reflection value plus the surface reflection value for that of the red. Okay, when this analysis is made, we'll now generate what we have in Edo State. Okay, so first of all, the remote sensing take image in pixel form, and when this is done, when you're looking, when I looked at Edo State, one pixel is not enough to cover that of Edo State, so several pixels was joined together via a process called mosaic merging to join the different pixels that was captured from the remote sensing instrument. So after that is done, we have different bands, like I said, different images is is taken at the same time. We have different bands, say from band 1 to band 12, either 2 band or 3 band. Combining that of red wavelengths and that of near infrared wavelengths, we can use it to get agricultural data. And that was what was combined. Following that expression, NDVI equal to S N arrow minus X arrow, subscript arrow, divided by X NI arrow plus X subscript arrow. Now, when this combination is done, we'll have a range between -1 to 1, where the lowest value shows the areas that does not have that have not been reflected at all as such that are water areas, while the higher values tending towards 1 are areas that we have green vegetations, green features, and that is how we know those areas that have forests, those areas that have crops, those areas that have berry land. So after that has been done, classification is made. This classification is similar to that of the classification carried out by Akamba in the year 2019. Now, but varies for the initial, which is that of the water body, and that of the dense vegetation. The difference in variation is due to the geographical location of this place. Now, a particular geographical location may not have so much forest as compared to others. And as such, for every location, the initial and the final value must always vary. That shows the difference in the features of those locations. And so this is not an exception for that of Edo State. We have variation in the initial and the final value. Now, after this has been done, the crop data was captured and kept aside, which showed in the figure in A figure by the A, while that of B shows the forest area. Now, the high dense or high forest area is stipulated with thick green. Then, while that, as it moves downward, you have light green and then yellow. The area that is shaded across board shows the area that do not have forest or crop vegetation. And so that was how the analysis was done. Now, the images that is captured is presented in form of a raster data. And now this raster data, after the classification, is converted into vector data, whereby we can now have the particular location, both the X and Y coordinate, as well as the longitude and latitude of this crop or forest areas. So if we check on the screen, you will discover that we have a total selected place. Total for that of crop land vector, we have about 182,155 areas that have been selected or mapped out, that has a problem. And that of forest also is different from this. So it shows that raster data can actually be converted to vector data, and this will help us to know the specific location where this forest or where this crop residue resides. And on doing that, one can easily begin to tell, if we are to cite a biomass plant, one can begin to tell the exact or particular location where those biomass plants can be cited, because where high crops reside, that's where we are going to have those are locations where we are going to have residues too. So it will help us to know specific area where to site this biomass plant for us to generate our power. In conclusion, biomass, crop, and forest residue has been identified as a good as well as a clean energy source that can help us solve power irregularity in developing nations. Nigeria, for an instance. GIS is an important tool that should be adopted by researchers in the agricultural and other sectors for appropriate mapping and planning. It will greatly improve the agricultural sector. I want to appreciate so much the organizers of this program for giving me the privilege to share my views and my research work in this regard. I'm open to questions and I'm also open to contributions. Thank you very much for listening.
Thank you very much, Mr. Michael. It was really a fruitful presentation and very informative. Anyone want to ask any question? Yes, or Ginrona, let me ask if you want to ask. Anyone from audience? Please ask the question because it's interactive session. It's not about to teach someone. We can discuss our problems. We can discuss our suggestions. If you want to have any compliment, then you may speak. Yes, please.
Yeah. Thank you for the presentation. It was really interesting. I'd like to know whether you are working with some partners or technology partners to actually make use of this data. It's quite good information. Are you working with anybody to deploy some certain kind of technology, and what kind of technologies could be deployed in the geomapped area? Especially, obviously, there is gasification, there is biogas. Both of these technologies will need different kind of data and different kind of biomass feedstocks. So how do you think which technology can be deployed, and whether you have any partners working on it?
Okay, I'm working with Dr. Rona from the University of Port Harcourt, and we are working hand in hand as to this regard, so as to we are also looking out to see if partners would come in to explore some of these resources that we have. There's currently energy access program that is ongoing in the Federal University of Port Harcourt, and I believe it's with is in this regards that this program was set up. So we are still looking for foreign bodies to also partners to bring up technologies to be able to venture into exploring the resources that we have here in Nigeria. So basically, this work focused on the assessment of the biomass energy that we have in the country. Now, like you've also rightly said, there are different technologies that we can adopt in converting this biomass energy. We have gasification and other, but gasification is one primary thing we are looking at, and any other technology that would be of great interest, that would be suitable for this conversion will be welcome. I believe that there are so many researchers here, as well as company fellows, that would be of best position to also help out in this regards to answer this. Yeah.
Thank you so much. Mohammed Sagir, are you clear now?
Yeah, thank you. Thanks for the answer. It's
Thank you
quite
so
good.
much.
Thank you.
Mr. Ali, do you want to ask something?
Yes.
Mr. Ali? Yes. Yes, please.
Good morning, and Eli speaking. Yes, I'm an MSc in energy access and renewable energy technology lead. However, I have this question for you. You, in assessing the data you presented, the biomass data, how are you able to account for the amount of this biomass that should go into food security? In recent times, we know about the rising inflation in Nigeria and the high cost of food. So how are you able to segregate what's available for energy from what the people need for food?
Okay, primarily, we are looking at using residues from this crop or the crop produce residues, which ordinarily is being thrown away, disposed indiscriminately. Some are being burnt as such, causing environmental issues. So rather than throwing away these residues or burning them, we can gather them and use them for energy generation, which will solve the energy crisis Nigeria is facing, as well as other developing nations. I don't know if that answers your question quite well. Are you clear with the answer? We are using the crop residue for the energy generation.
If we use the crop residues, how sustainable will this be? How much volume can we generate over time? Won't it be good to have a plan to cultivate crops the way they are doing in Brazil and all these places in terms of sustainability?
Okay, now there is a model we're trying to develop using what we call Huber equation, so as to tell as this agricultural crop is being used, the amount of crop to also plant back to be able to make it sustainable. Now, another thing is that so long man exists in a place, he's bound to eat. And as such, there would always be food in that place. Now, as you eat your food, you discover that there are residues that ordinarily, rather than throwing them away, we can use them to generate energy. So as the population increases in a place, same thing, food production is also seen to increase in that place. And as such, the residue obtained would also increase. So there's an equation that we are looking at developing using a Huber equation, so as to ascertain the amount of these residues to be used at a given time, so as to make the consumption or the utilization of those products to be continuous. So we'll not use it all at once in 1 month, and then we'll now have to wait for the next season before we start using those technology to generate power again.
Understood. Thank you.
All right. You're welcome.
Thank you so much, Michael, and thank you for such an interesting discussion. Now we will move towards the presentation of Dr. Muhammad Aziz. He will present on the topic of application of remote sensing data and techniques to crop type mapping, growth, monitoring, harvest detection, and biomass waste estimation. Dr. Muhammad Aziz, Earth Observation and GIS Executive, Pyrogenesis Limited. Welcome, Mr. Dr. Muhammad Aziz.
Good morning or good afternoon or good evening, depending on which part of the world you're joining from. Can you hear me loud and clear?
Yes, we can hear you well. Please continue.
Thanks so much, Mrs. Rikza, for your introduction. So I'll just go ahead now to share my slide. It says host disabled participants, so I think I need to be given sharing rights to be able to share my screen. I still don't have sharing rights. The host needs to give me a sharing right.
Okay, let me make you a co-host.
Okay.
Risek, are you able to do so?
Yes, I think I'm actually in the process of doing that now. Thank you so much. If you give me 1 second. Right. So can everyone see my screen okay?
Yes, we can see your screen.
All right, thank you so much. Yes, my name is Dr. Mohammed Is, and I'm an Earth Observation and GIS executive with Pyrogenesis Limited. And the topic of my talk today is on the application of remote sensing data techniques and techniques to crop type mapping, crop growth monitoring, harvest detection, and biomass waste estimation. And yeah, so just to give a brief background on what pyrogenesis actually does. Pyrogenesis is actually a bioenergy technology company, and the technology itself basically ingests waste from agri-processing factories and agricultural residues. And this waste is actually processed through a process, or is actually processed using a process called pyrochemy to generate a wide range of byproducts from bio-oil, renewable heat, electricity, and biochar. So from the work scope of pyrogenesis, use of biomass and residues and agricultural waste is actually very, very paramount. It's very, very key. So the challenge for us essentially is to be able to use a modular technology that can assess the availability of resources on a very wide area, on a very wide scale, so that we're able to identify the best location to locate the machines. So the machine basically needs agri-waste, agri-residues, and biomass products as feedstock to this machine. So just a brief background on remote sensing, because I'm an Earth observation specialist. So remote sensing, just like the previous presenter emphasized, is actually the science and art of obtaining an information about an object without necessarily coming in contact with that object. So if you relate that to how the satellite works, you have satellite orbit that revolves around the Earth on a near daily basis, I mean, on a very regular basis. So you have satellite revolving around the Earth, and when they revolve around the Earth, they acquire satellite images through a process called, through a process called reflectance. So essentially, the satellite sensor in orbit gathers information about the surface reflectance of features on the Earth. So energy from the diagram here is reflected. So energy is actually beamed from the sun to the Earth, and that reflected energy is what the satellite sensor uses to generate satellite images. And we have two major types of sensors. So we have both active and passive sensors. Passive sensors actually are the ones that rely on the emitted energy from the sun to generate satellite images, while active sensors actually propel energy from itself, like they depend on their solar panels to generate energy, the beam energy on the Earth's surface, and then that reflected energy is what is used to generate satellite images. And both of these satellite images the first one is called an optical image, and while the second one is called the SAR image, that is synthetic aperture radar image. And both of them are needed to carry out good feasibility study to identify the best location for, the best location that has huge amount of biomass or cultivation in process that will support our machines in this case. In order for us to carry out our process, we rely on what we call the crop biomass estimation process cycle. And it's a combination of 4 specific activities. So The first is to carry out crop mapping. So crop type mapping itself entails getting satellite images and then running a classification operation to help you distinguish between different kinds of crops, because biomass from different crops weigh differently. So we want to be able to know what kind of crops are cultivated within a particular area and then be able to estimate the biomass of that particular type of crop, because the allometric equation for a rice farm is different from a cassava farm and is also different from maize. So crop type mapping is the first step that we usually that is necessary to enable us reach a final conclusion on the biomass estimation. And the second process is crop growth monitoring. So we also carry out crop growth monitoring just to help us understand the health status of the crops or the crop fields, as it were. Because if we have to be able to establish or estimate biomass, we need to be sure that the field we're estimating from actually has a good growth cycle. The crops, they're actually healthy, because if the crops are not healthy, you won't be able to get the maximum biomass from the field. And the third process is to detect harvest. So harvest detection, we rely on satellite images as well to help us detect the exact date that harvest actually took place in a particular field. And this in itself is supposed to help us plan the process of feedstock management for the machines. So because if you want to, if you don't have an insight as to when farmers usually harvest, you end up with a lot of biomass or residues at the same time, and that would lead to wastage. It would lead to lots of, you have excess material essentially for your use. And then the fourth process is the actual biomass and agri-waste estimation. So for this process, we use satellite images. We integrate both optical and radar images to help us estimate biomass from a particular field. And then once we have an idea as to the biomass of that field, we're able to extrapolate the amount of residues that we expect or that is expected to come out from that biomass from that particular field. And then the fifth process is the annual annual feedstock planning activity. So going to the first content now, which is actually on crop type mapping. So the previous speaker actually talked about land use land cover maps as an essential ingredient or tool for crop type mapping. And this is actually the case here as well. So we rely on existing land cover maps. And this is because we know the source of our land cover map. And the source of our land cover map in this case is actually the European Space Agency Climate Change Initiative, which is the ECCI data on the top right corner of your screen. So the land cover map itself comes with a lot of classes. So from dense vegetation to shrubland, grassland, land, and all the way to water body. But our emphasis here is actually on cropland. So what we did, or what we usually do essentially, is to isolate cropland, and then in our own case, we actually developed a method that helps us defragment that cropland into different crop types. So what you have on the middle of the screen here, which has the green and purple color, is actually a crop type for an area within the southwestern part of Nigeria in Ibadan. So the green color stands for cassava cultivation, while the purple color represents rice cultivation. And so on this particular slide here, what I did here was just to make a comparison with a high spatial resolution image. And from the two screens, from the two subsets at the top there, the crop type map was actually viewed at a very large scale. So at this scale, you're not able to see very tiny details like the farm fields. And then on the two pictures on the bottom actually compares the crop type map to a very high spatial resolution image in this case. And you can automatically pick out the fields that the crop types are assigned to. And if you notice, you have a concentration of rice farms along the riverine areas. And this is expected because most of these farmers actually rely on the water body from that river line to carry out irrigation farming during the dry season. So that's for our crop type mapping. For crop growth management, like I said, it's very essential because we want to know when crop actually attains its maturity and then be able to extrapolate whether the field is good enough in terms of biomass content. So for this, we rely on what we call multi-temporal data sets to gather information on crop type, on crop growth really. So from the screen on the top corner of your, just where my cursor is hovering over, this is like a line plot showing the crop growth within a year cycle. So at the beginning of the year, you notice that the signal from that particular field monitor is actually very low. And this is because it's actually still very early in the year. So the crops are still at the early stages, still they're still developing. So, but as the year progresses towards the middle of the year, where you have peak rainfall, you notice that the crop signatures are actually higher. So in this case was an NDVI. So the NDVI, that stands for Normalized Differential Vegetation Index, is actually an indices derived from satellite images that tells you, it informs you on the greenness of the vegetation. So areas with peak green, with areas with high NDVI value stands for areas with a very thick biomass, or areas with very high quality greenness for the vegetation, as it were. So at the middle of the year, you have very high NDVI value. And then as the year winds to a close or to an end, you notice that the NDVI value actually reduces just close to the end of this line plot here. So this is because, you know, senescence, that is dry season, actually begins to kick in, and then for that reason, NDVI value significantly drops. So, and then at this point, we're now left with trying to establish the date farmers actually harvest. So for this process, we also rely on high resolution satellite images, both from the optical sensor and from the radar sensor, to help us detect the exact date that harvest took place. And in our own case, we're able to develop a state-of-the-art methodology that actually helped us to map the extent of the extent that different farmers actually harvested for the different parts of the year. So from the legend on the left corner of my screen, you can see the areas that were harvested from April all the way to December. And in this case, it was very obvious that lots of the farmers actually harvested their field towards the end of the year. And this is also expected because at this point, there is the crop has actually reached its maturation, and then, you know, the crop is actually very, very ripe for harvest, and that is the beginning of the dry season as well. So areas with dark or deep blue color actually fields that were harvested towards the end of the year. I think this was 2020. So this is just comparing results from our harvest detection to high resolution images. So the same thing, I mean, you can also spot out fields, agricultural fields in this case, you know, made up of this tiny square. So these are all smallholder farmer fields that were under cultivation, and you can see the dates that harvest were actually, or the dates that harvest actually took place on that particular field from April all the way to December. So so the third or the fourth and most crucial stage of our operation is the biomass estimation. And for this, we actually rely on both you know, images from optical and radar sensor. And the reason for this is because optical sensors are actually constrained by clouds. So you have lots of cloud cover within the tropical region where Nigeria and other West African countries are actually located. And then with SAR sensors, they are not inhibited by cloud in any way. So we tend to integrate both sensors together and then do an extrapolation. We actually developed a methodology that helped us to estimate biomass for our area of interest, which was in Nigeria and parts of Liberia and Sierra Leone as well. So, having done that, we actually also relied on some of our partners to give us field data sets. And this field data set was actually used in both the calibration of model and the estimation. So we calibrated models, we estimated, and then we also validated the final results as well. So this is what our biomass map look like. Areas with the deep green color are areas with high biomass, and then areas with orange color are actually areas with very less biomass, which is also a factor or a function of the crop types in that particular area. So based in conclusion, the number of Earth observation satellites in orbit and constellation missions. So as we all know, there are a lot of satellites are being launched on a monthly to yearly basis. So that in itself gives us the ability to carry out repetitive monitoring of farm fields on a regular basis, and also gives us the opportunity to detect harvest and to also estimate biomass and extrapolate for agricultural residues. And then, yeah, so basically this is actually our story in pyrogenesis. So basically we rely on Earth observation satellite images to map out crop fields, monitor the growth of the crop field, detect the harvest or detect when harvest took place, estimate the biomass from fields, and then extrapolate what the agri waste is likely going to be from the farm field itself. So that helps us to plan the amount of residue that goes into the pyrochemistry machine. And yeah, I think that's my submission for now. Thank you for listening. Hello.
Thank you so much, Dr. Muhammad Ozigi. Thank you very much for such an interesting information. Anyone wants to ask?
I was talking to myself, really.
Anyone wants to ask any question? Or wants to add some compliments, some suggestions? Okay, our next speaker will be Mr. Abdul Hanan. He is GI specialist from SAWiE. Welcome, Mr. Abdul Hanan. You may present your presentation. Thank you so much.
Thank you so much. Can you please make me, okay, let me share my screen. So, is my screen is visible to you?
Yes, we can see your screen.
Yeah, thank you so much. Actually, my name is Abdul Hanan, and I'm from SAWiE. SAWiE, actually, I'm the head of remote sensing and GIS in SAWiE. So the SAWiE stands for basically, I will let you know about the brief introduction of the SAWiE. So SAWiE means Sustainable Agriculture, Water and Intelligent Ecosystem. We're giving the impartial advice to improve income through digital connectivity and sustainable use of soil, water, natural resources, and biodiversity. Basically, our end goal is to empower the farmers using these impartial advisory services to grow more with less. This is our mission, vision, and actually we are registered in Pakistan as well as UK. So our plan, we are now currently working in Pakistan, and what's our purpose in Pakistan? So our vision is to use the remote sensing and GIS data sets and artificial intelligence to help us, the farmers, in decision making. So our mission is basically to reduce the cost of the farmer and to reduce the waste of the farmers, to reduce the fertilizer of the farmer, basically, which is used in the field. So the end goal is to increase the yield of the farmer, in which we can use all the data sets of remote sensing and GIS we developed the AI models and machine learning models for decision making. So basically our process to combine the artificial and the human intelligence. These are the 4 steps basically we are using in SAWiE, and the number 1 is basically the data acquisition, which is done by the drones, and which can also be done by the satellite imagery as well. So in the data acquisition, we can manipulate the multispectral and RGB satellites images, and the second process is basically to digitize these the farmer locations, the GPS locations, and the farmer's area. The third one is basically the data science. Data science is most important component in our organization. Basically, we already developed the AI models, machine learning models, which can acquire the data sets, to compile the data sets, and at the end goal is basically to solution implementation for the farmers. That farmers can easily access to the technology, and they can easily make a decision on their farms as well. So today's basically presentation is about the biomass energy in Nigeria. So I will briefly explain just short introduction of the SAWiE. So the potential resources for biomass energy in Nigeria, basically. The total there are in my right side, the pie chart is showing basically the animal waste, forestry residues, and MSW, contribution of basically biomass resources to the all overall technical potentials. Animal waste is basically is about 28%, and the major role is basically of agriculture and forestry as well. So the right side, in my left side, there is a graph, there is a plot showing basically the sheets showing is agriculture potential sites, and the bottom is showing basically the potentials biomass agriculture in forestry side. So if we talk about the estimation of biomass using remote sensing and GIS, that what type of data sets we are using, and how we can compile and interpolate these data sets. This is basically the little bit methodology. Some of our colleagues are already described about the GIS and GIS classification, and land use and land cover classification. Both all the topics are covered. So my goal is to basically how we can determine the biomass, the actual basically the actual content of the this workshop. So the first step is basically to pre-process the data sets, in which we can collect the data sets from LiDAR, from I would say that satellite, from drone as well. So basically, then we classified these point cloud data sets. Basically, point cloud data sets is derived through the LiDAR only. So if then we interpolate with the digital elevation model. Basically, this is DEM. DEM is used for digital elevation model, which this is the raster layer of I would say that the elevation which is above the mean sea level stored values in their raster pixel, which is above the mean sea level basically. So DEM is stands for the digital elevation model. Then we can interpolate it with the DEM, and after detrending, then we will find the flat surface, which is basically the normalized point cloud. Then we can easily detect the individual tree using LiDAR, and at the end we can determine the biomass map, basically in which the last region, the black pixel are showing basically the last biomass contribution, and the red pixel showing is basically the higher biomass contribution, and the green pixel as well. Green pixels showing more and more biomass contribution in that. This is basically the little bit methodology of biomass, estimating the biomass using remote sensing and GIS of forestry. So thank you so much. This is all from my side. So over to you, Rikza. If anyone has questions, please let me know.
Thank you very much, Hanan, for sparing your time and for presenting such a informative and very informative, actually, presentation. Anyone wants to participate in this discussion? Anyone wants to ask anything? Please raise your hand, or you may write in the comment box. Dr. Oginirana, do you want to ask something? Because you are the very experienced and senior one.
Okay, not really adding something. Maybe the emphasis of using remote sensing and GIS is to aid the decision making in regards to the size of the biomass energy conversion technology that you want to size in a particular place, and then to help determine the appropriate location, considering economic constraints, technical and resource constraints. Also, and from the transmission, what you are generating, there's supposed to be end users. So the GIS and all those remote sensing, put it there together, we actually the capacity to make decisions that will solve economic, technical, and political constraints, or the demand constraint. So that is the essence of using the GIS, and also advancing it is just because there are numerous technology in biomass to energy conversion technology. The feedstock, a particular feedstock that we use, GIS will be able to tell you that based on the remote sensing, you can classify the biomass on the type of refraction that they are giving. So you can say, for example, this zone is for cassava, and once you know the proximate and all the other analysis of that particular feedstock, you will say, okay, this is the best technology for it. So the remote sensing could also help in that. So in general, the essence of this mapping is to arm ourselves with the capacity to make appropriate decisions going forward in developing biomass to energy conversion technology. Thank you.
Thank you so much. Now it's a time to move for panel discussion. I would like to invite Dr. Muhammad Imran, Senior Lecturer from Aston University, Mr. Abdul Hanan, Head GIS from SAWiE, Dr. Muhammad Azigi, Earth Observation and GIS Executive, Pyrogenesis Limited, Dr. Oginirana, Senior Lecturer, University of Port Harcourt, Nigeria, Professor Dr. Rasool, Director, Center of Advanced Studies in Water, Mehran University of Engineering Technology, Jamshoro, Pakistan. Welcome everyone for panel discussion. And I think so, some of the participants are not present here. So Dr. Muhammad Azigi and Dr. Oginirana, you may start panel discussion. Rest of the people will join after some time.
So the discussion, is it going to be question dependent, or how do we organize it? Maybe the participants ask questions, then we respond in general context.
Okay, it's my humble request to audience, please ask questions, especially people from Nigeria and people from from Pakistan universities. You can see that people as well.
I think before now there was a question about there's possibility of exhausting the feedstock in a particular place. that may likely ground the power plant? I think that question needs to be addressed properly, and it's very, very important. Partly, Mohammed Zigis, I think he answered part of the question, in the sense that from the analysis, they will be able to tell when they do the harvest, the amount of waste being generated from that particular region. And once you know the amount of waste being generated, that could constrain the sizing of the power plant throughout that year, because you know the time of harvest and also the waste being generated. So with that, you'll be able to do that, to say, okay, if I'm generating so amount of waste based on so potential, but you've locked in the economic potential, you lock in the technical potential, and deriving it from the theoretical potential. So one will say, this is the size of power plant that we put in this region that will serve throughout the year based on the information we got from the remote sensing and ground site visit validation. So that one is one way. Then another way that I also tried to stress the other time was to use the Huber's theory that could tell you the potential reserve for any energy resources. If applied it in petroleum industry, that is what they use to say, okay, this is the capacity of so reserve in so country, and it will last for say 20 years. So we try to apply that in the renewable and the biomass energy space to know if for a particular area, this is what they need to generate that will make the system a continuous process, not use and ground. So basically, so issue or other issue, social issue in the context of Nigeria, some of the waste, they also use it to feed animals. So what amount of this waste that will be available for power plant, they also use it, they can still convert it for other means, the valorization method they also use. So what amount of the waste that will be remaining for power plant? So those are the things we need to get from ground visit or site visit. So this is what you are producing. What percentage of it do you use to feed the animals? What percentage do you use to do this? Let's take a case of oil palm fruit. You have a palm kernel, you have the bunch. In Delta State, what they do, the bunches, they burn them to produce soap, call it local soap. So, and once that one is done, that part will not be available for the power plant. So by the time you put all this into consideration, you will now know the amount that is ready for technical firing of power plant. That is where the technical potential comes in. Then human is human. Once people get to know the waste they are generating is being used for a positive thing, the economic benefit people will try to attach to it. So that consideration in terms of social consideration, it has to be considered in the business model that you will build. Maybe a kind of credit that you go to the people that will, that when they supply, the farmer or the smallholder farmers, if they supply amount of waste, this is what we discount from their billing, energy they will use from the power plant. So those are the things we can factor into the business model. Thank you.
Yeah, I think I agree with you, especially on the aspect of the amount of waste that should actually go to the bio oil process and the amount of waste that actually used for commercial or economic purpose. And I think from my own personal experience, when we're actually out on the field to assess the potential for cassava residue for bioenergy production, we actually came to observe that the cassava peels that we actually relied on as going to be our feedstock were actually commercialized. So most farmers actually sell their cassava peels to herders, essentially. So as they peel the cassava, they actually feed it out. They actually sell it to herders to feed their livestock, their cattle. So it was at that instance we realized that the use of cassava fields may not necessarily be very economically viable for our machines. So we had to look for other alternatives still within the processing chain of cassava. So other alternatives were explored, like the stems and the roots, or that's the root part of cassava crop, essentially. So that's the place, that's the region between. So essentially, so that's part of our experience as far as the raw materials are actually concerned, essentially, yeah. So, but yeah, I think it's a very wide discussion, really. So questions would actually.
I just want to add here what Mohammed said, and my name is Khalid. So just, I think this is the biggest concern. I mean, where shall we grow energy crops? Where do we grow the food crops? So this competition between food and fiber, or food and energy, this is a challenge. So I just want to maybe hear from you, what's the priority of the Nigerian government? Is this something they are putting some kind of a support specifically for farmers to grow energy crops in areas where you cannot grow other crops? So what is, and absolutely this is livestock is the biggest consumer of the roughages or anything that's left out from other crops. So I think this is a challenge. So how do we manage this expectation, food, fiber, or food, energy? So over to you. Mohammed, over to you.
Yeah, I mean, for me, I think for you to manage expectation means that you need to have very good understanding of the crop you actually that is actually your that is like the crop that is that you're actually focusing on. If you're focusing on rice, you need to understand the entire processing chain of rice and understand which part of the byproducts of rice would be suitable for your bioenergy. And then it also means that you have to do like a proper investigation of what is on ground. You know, what kind of crops are being cultivated, and then what amount of that waste products are commercialized, what amount of the waste products are being thrown away or left out as the real waste in this case. So I think proper investigation, proper field work, proper interaction would really serve to provide all the information that you need to help, to help with your own business, as the case may be.
Is there a, I would say, special, I mean, I know the forestry is obviously one choice, but is there any other sort of crop, or is there any incentive for farmers to grow energy crops? And then if you compare with maybe if it's a coffee or cotton or sugarcane, so what, I mean, the farmer will have to, the choice will be always the income per acre. So were there any studies carried out in terms of where you could compare the cost benefit analysis?
Sorry, is that for me?
Maybe who else is there on the?
Yeah, I think I'm more focused on the Earth observation.
Sorry,
side.
I think
yeah, maybe
I had okay.
Yeah, maybe Professor Ogunadaro. Sorry, my pronunciation is really bad. So, Professor, over to you. Maybe you could give us any hope.
Yes, I was actually saying that I totally agree with Mohammed that we need to do proper site investigation after carrying out the remote sensing and the GIS application. From the theoretical perspective, then we're now going to real practical issue to validate whatever that we've done. But the interaction, which is complex, the complex interaction between food and energy in terms of waste generation needs to be properly investigated to ascertain the amount that will be available for the power plant now and in the future. So we need to do a kind of forecasting too. There are special forecasting tools that we could use to match that. But from the policy perspective in terms of Nigeria, I have not really seen in the policy document of Nigeria where they specify particular acreage for energy crops. I have not actually seen that, but it might be there. But yesterday, when I started my talk, I actually stressed that there are numerous policies in the domain of energy access in Nigeria, but implementation is another issue. So there is wide difference between policy target and what is on ground. So energy, food, water is a complex interaction that needs to be investigated properly before establishing any biomass power plant. Why I mention water is that in the course of operating power plants, biomass power plant, their effluent could be a source of pollution to water body that the people are relying on, or even seepage, underground water flow could contaminate water body around that region. So it needs to be dealt with properly in siting biomass power plants. Thank you.
Thank you so much. I think that's very useful. I think this is a sort of a question always we have to keep in mind. So energy, water, food, energy, water, and access. So this is a sort of an ongoing challenge, and especially when this comes down to when the fossil fuels are getting expensive. So, but at the same time, the food is getting expensive as well. So we have seen that peak back in 2008. Remember when we had a financial crisis, the food prices are going up, and now we have the same situation now with the war in Ukraine and the issues around climate change and issues coming from the COVID. So now we have a pretty dull situation where we would be making progress. So it's not that easy. So it's going to be a challenge now. I mean, the fertilizer price is going up as well. But if we have to rely on something which is a crop which is not used at the moment, or a biomass which is not used at the moment, and an area which is not used for growing crops. So some area which is, I would say, purely, or it's not very productive to grow other crops. Maybe if there's an area where you have salinity. So ideally, if we can use an area where we can grow biomass crops that they're hardy, they can grow on biosaline or drought conditions, that would be ideal. And it will be a double fix in terms of fixing the carbon, the issues around the capture of the greenhouse gases. So I think forestry and it plays a vital role. But now this is a question, how do we find a balance? So this is going to be anybody maybe outside the panel have some view. Maybe I would like to hear from them as well.
Dr. Sadir also wants to participate. Dr. Sadir, please speak up.
Thank you, Riksha. I think my understanding is whenever there is a potential for biomass to come in competition with the energy, there is a great likelihood that the current uses of biomass will have better value addition in terms of economic development and the cost to discourage the energy usage of that material. I mean, let's say if we take, for example, some sort of cassava waste, for example, I think they will always get better value if they use it for animal feed rather than doing the energy conversion. Although energy conversion can be done, but I don't think there will be enough value addition in this. But secondly, I think Dr. Khalid, you already kind of answered this. The first priority is always, I mean, we are trying to scope projects both in Nigeria and Pakistan. We are only looking mostly at non-edible elements of the biomass residues. And this is mostly either bagasse or it's cotton sticks, for example, in Pakistan, or rice husk and sometimes straw as well, which is normally burnt in Pakistan. We haven't even considered using for example, wheat straw, which can potentially be used, but already it's well in demand for animal feed or as animal fodder. So I mean, there could be cases where the value addition through energy conversion might overtake, but I will doubt it, because if you are already using it for animal feed or in other value added pathways, then energy conversion may not be economically feasible anyway to discourage the competition.
Yes, Mr. Sagir, we usually use rice husks, rice stubbles, wheat straws for mulching purpose as well. And it's also a great value addition.
Absolutely, and I'm not questioning that, but I think those uses could also be carried on in parallel, and perhaps even after that, some biomass could be recovered. But there is huge rice straw already being burnt in Pakistan and India, for example, and I'm sure in some other developing countries where after going through the combined harvester, nearly about 10 to 12 inches of straw is left in the field, and sometimes it's burnt or it's just tilled upside down into the soil, and that resource is lost. So we have worked on a project in India where we have made use of that remaining straw in the field, and that could be recovered. Or there is a project in Philippines where they are bringing new type of combined harvester, where they can recover all the straw in one go and use some of it for energy conversion process.
Okay, Dr. Mohammed Seer, I want to ask something. Suggest what should we do? Like we got very less water in our dams, and we are running with short, less electricity problems, and there are a number of other problems. Or we can produce our own electricity other than water. In Nigeria, you people are working for biofuel, biomass from different resources. What would you suggest for Pakistan as well?
Well, for Pakistan, the problem is slightly different. I think we have huge biomass available. Electricity production in winter is more than the actual consumption, actually. I mean, I sat in a couple of meetings with the government officials in Pakistan. There is net access electricity in winter in Pakistan. So this electricity problem only arises after winter and mostly in summer months, and that is linked with a lot of industrial activity, but also with the air conditioning requirements. So in Pakistan, I think the most optimum option is we should target the 30% population which is not connected to electricity grid. And also we need to look at, and a lot of time in Pakistan, when people talk about the energy, they mostly talk about electricity. They forget about gas. They forget about biomass and other uses, which can be enabled through utilization of biomass to even meet the gas needs. Because a lot of countries' population in Pakistan is not connected to gas grid, but also electricity grid. So rather than generating powers and feeding the power in the national grid to actually produce the electricity that way, I will suggest we should target biomass usage in rural areas where there is no access to electricity or gas. We can address both through either syngas or biogas, but also through power conversion to address the access issue for that remaining 30% of Pakistani population at least.
Very well said. Thank you so much. Dr. Mohammed Khalid, do you want, Anthony, you want to ask any question, please?
Yeah.
Okay.
Okay.
Good morning from Nigeria. Okay, what I want to contribute, I thank also the panelists and all the presenters that have made their presentation today. We've learned a lot. And I thank the organizers of the event for putting this up. Okay, what I also want to contribute is as regards the food, energy, and water nexus as it concerns energy generation through biomass waste. In Nigeria here, and from what I have personally seen, which also informed my decision, my undergraduate project, which we worked on, converting rice husk to heating gas. What we found out was that this husk, the waste that is generated from this rice processing, is being dumped in a large quantity around the rice mill. So I feel that the waste alone, if the waste is being utilized properly, it can also serve not just providing electricity to the general populace, but to the farmer himself in the processing of his rice. If he decides that, okay, I'm bringing my rice to process now, and after processing my rice, the husk itself is still going to give me, there is still a value that can be gotten from the waste, the waste that will be generated from it. So I think it will help also boost participation in agriculture, because it will go a long way in engendering more profitability in agriculture, and thus make youth more willing and likely to enter into agriculture. So that's my contribution. Thank you.
Thank you very much. Thank you very much for your participation. Anyone wants to ask anything? Anyone want to participate or suggest something?
Can I say something?
Yes, sure.
Yeah, mine is completely on clarification. I think another way to look at the availability of biomass resources for power generation would be to combine different agro waste instead of relying on a particular agro waste, maybe single agro waste. So, and that leads to my question or clarification. I think it's to Mohammed Sagi. The system you designed for a location, is it targeting just one agro waste, or it could be targeting a combined feedstock? For example, cassava peel, palm fiber, or palm bunch combined to feed that particular system?
Yeah, very good question. And yeah, I mean, a lot of people are quite well aware of these issues. I mean, first of all, to run a plant of a significant scale or at economy of scale, you cannot rely on one type of biomass, because it will need sort of tonnage which cannot be met from one feedstock. You need year-round kind of availability of different types of feedstocks. So your technology needs to be capable to handle different types of feedstocks. The technology which we developed, and based on our experience and based on my personal last 12 years experience, we have developed a system which is not reliant on one type of feedstock. We can use anything and everything from RDF, which is refuse derived fuel, up all the way to animal manures. We can use a lot of different crop residues, and we can use forestry residues and waste. And obviously, we can also use plastic in our system. So our system is not a gravity bed system, or it's not a bubbling fluidized bed system. Our system is an auger driven system. So we have the ability to move the material through our reactor. And we have the ability to change the conversion ratios, whether we want to produce more biochar or solids compared to the syngas, for example, or the liquid biofuels. So there is always a possibility that we should aim to maximize the feedstock diversity to ensure that the process economics can be justified by low cost of the seasonal availability of the biomass. I mean, if you are only relying on, for example, let's say bagasse or cotton stick or cassava stem, for example, you will only be working for so long unless you develop some sort of a huge storage capability and maybe some other pre-treatment combined with storage to enable yourself a year-round operation of the plant. And if you can avoid that, because these will add a lot of capital costs, a lot of other storage issues, biomass decomposition, and so on. So to avoid all these problems, you need to have a technology which can use all kinds of feedstocks, whatever is the availability, whether it's in small quantity or large quantity. And most importantly, we don't need massive hundreds or thousands of megawatts of plants installed to have energy application. We can have small scale plants, maybe less than a megawatt is kind of ideal. And also to support the local economy and also to minimize any foreign direct investment, you need to make it small scale. If you're making it a bigger scale, nobody locally will be able to afford it. You are looking at international funding institution to actually support your project, and that becomes a big hurdle. And the project which you could have done in 2-3 years may take 5-6 years in that case. So there are all sorts of other variables which come into play, and certainly one of them is the diversity of feedstock. I hope I answered your question.
Excellent. Thank you.
Thank you.
Thank you very much, Dr. Mohammed Sagir, for creating interest, and Dr. Orginarona and Dr. Ozigi. Everyone, thank you so much for participating in this workshop.
I just have a question. Sorry, Erixa. Can I just raise my question? I just want to ask Dr. Sagir, because Dr. Sagir, you're doing a lot of work again using the waste. So have anybody looked at using the wastewater to grow some species? I don't know if it's algae or anything in terms of other species. So everything we have talked about today was forestry or wood. So using the algae or something resource on wastewater, industrial wastewater, or maybe the municipal wastewater. Is there any interesting examples to quote or something we could explore? This way, maybe it could be a double advantage as well, cleaning the water and also producing energy, cleaning the air as well. So air is another area. So carbon emissions is the biggest issue for Nigeria as well, I would suppose, yeah.
Yeah, very interesting and very relevant question, and especially to address the net zero ambitions of developing countries and also the developed countries everybody should be aiming for. I think there is a lot of interest and research going around utilizing wastewater for algae production. We haven't personally got involved into this yet, but it is a very interesting area. Apart from algae, actually, there are quite a few other kind of aquatic plants which can be grown. And also at the same time, they can be fed with the carbon dioxide laden emission exhaust gases from different power plants and other sources. So for example, there is algae. There is another very interesting thing. This is called azolla. I'm very interested in azolla. Actually, we grow azolla already. Azolla is a macroscopic fern. It's not actually an algae. It's a fern plant, and it has the ability to kind of process nitrogen from atmosphere and lock itself into its own molecular structure. And a lot of time, this is already being used in Southeast Asia and Far East Asia to actually support this hybrid cropping system with rice and duck farming, and people also harvesting and growing azolla with that. But I think in future, this might make a very good sense, because azolla is not just any kind of aquatic plant or a fern. It has more than 25% protein, a lot of amino acids and vitamins, and it's already being used as a fertilizer and also as an animal feed. In fact, some people in India already use it as for human consumption. They make something like fritters from this azolla. I mean, we have used it in Pakistan. We are experimenting with the azolla to actually grow the chicken feed, or compensate the chicken feed cost through usage of this azolla. And likewise, there is duckweed and a lot of others people are quite familiar with. But definitely, it makes a very good sense that we should integrate different technologies. And this is where I think innovation comes into play, and things are still at early stage. For example, growing algae itself is very new and early thing at the moment. There is no economic case or economy of scale kind of cultivation taking place, but it will happen. Costs are very high compared to other means to grow things. But if we integrate different technologies, I think it will definitely help. But most importantly, these carbon credits will, I mean, once it's become more mainstream and there is higher value to carbon credits, I think absorbing carbon from these exhaust gases and locking them into azolla or algae, and then reusing and bringing these material back into circular economy will become a big hit. And yeah, definitely some more integration needs to take place in this area.
No, that's very beautiful. I think azolla, I love azolla because it's high in protein as well. So you can feed to livestock as well. So that's another thing.
Absolutely.
Yeah. I know there's issue with when you go to the livestock. So livestock have also issues around methane emissions. So I don't know, there could be a way we can capture methane from livestock. So I don't know.
Well, there is, yeah, you just talking the right things, which I'm very interested.
Okay,
we already using
on that one.
Maybe for other people's, other people can benefit from this conversation. So there is already some studies taking place in Germany, Switzerland, Australia, China, even America, where they are feeding the biochar to animals and to actually capture some of those methane emissions in the biochar, because it helps to actually reduce the methane emission in the first place, because there is less organic content, less volatile organic content in the biochar itself, because it will still come out as an inert material. It adds to capture some sort of carbon emissions or lower the carbon emissions. So biochar can then be obviously put back into the soil, or it can go through the cycle again through the manures, then soil, and then goes back up. But I mean, there is an interesting use for biochar in animal feed. We are already eating it, by the way, in the form of, I think there is an E number for biochar. They call it vegetable carbon. It's E151 or 51, something like that. I forgot the exact number. We are already eating the biochar, by the way. It's just that there is a little bit more carbon content and some ash has been removed, but it's mostly the same old stuff, biochar, which we have.
No, brilliant. That's great. I think I'm a great fan of this whole circular economy. So I think we have researchers just think about it. So it's not a this is an open opportunity, and I'm really glad today our colleagues from Nigeria, from the UK, and from Pakistan, they have participated, are also from around the world as well. So, and sharing good practice and sharing these because the world is a global village. We all have a responsibility to protect our environment and not getting the word to this earth go beyond 1.5. So how do we keep under 1.5 degree increase in the next 100 years? So this is a equal responsibility on all of us. Okay, great. No, thank you so much. Sorry, Rixa, I just...
I would like to add one or two more things before we finish. And I think it's important that we share the knowledge which we possess, and everybody is kind of getting into grips with the current development. So a lot of time, is that okay, by the way?
Yes, I think should be okay. We have time. And I would also encourage students to ask some questions as well.
Absolutely, yeah.
So
please feel free.
Get them excited as well. Yes, please. Yeah.
Thank you. So I think we talk a lot about technology, biomass to energy and bioenergy and so on. But I mean, things can be very simple as well. Don't think of technology being a barrier, or access to technology or development of technology being a barrier for your country's economic development or to address the carbon emissions and greenhouse gas emissions. We can always, and definitely we can all do this. This is by compacting the biomass, either turning it into pellets or into briquettes, or even shredding it. For example, something like cotton sticks. Shredding it, we can bring it into a more usable form, and we can provide access to millions of people to utilize this feedstock rather than, for example, coal or LPG and a lot of other fossil-based fuels. So, for example, we can make briquettes and pellets or chips to use in clean cooking. This is quite good use, and it doesn't need any huge technology or some certain expertise and detailed understanding of things. I mean, this can be quite small scale. Even if you process something like a ton per day, that's 8,000. That's 300 tons per, or 300 plus tons per year you can process, and it's a quite niche, little business idea for some people in developing countries, where you can produce, for example, let's say if you see that there is a lot of palm industry waste or cassava waste, convert it into chips or briquettes or pellets and use that as your business model to actually reach out to the clean cooking community and address the gas shortages, or for example, where they are using coal or they are using LPG, you can compensate some of that. So we don't need huge investment. We just need willingness that we can contribute in this area.
Yeah, I think, Mohammed, thank you very much. It's a good idea. But I think the emphasis, we should also consider the indoor air pollution that being emitted by all this crude way of burning biomass. For example, someone could actually develop a business model along cassava utilization, turning them to briquettes and the rest, sending them to the rural community. But it will also end up with the 3-stone cooking services. So at the end, the indoor air pollution is also a major problem that has not been solved. So I think while we are thinking along that line, we should also think along developing a suitable cook stove that will be adapted to that will minimize emissions to reduce the indoor air pollution. Thank you very much.
Yeah,
there's
absolutely.
also a technology that could also be used. It has not been mentioned all through our conversation because we are just emphasizing on power generation. Torrefaction is also something that we could also look at. It has shown that it can actually increase the heating value of biomass and reducing emission in the course of utilization. So we can also use look at that from that perspective of reducing indoor air pollution. Thank you.
Absolutely. And I'm a big believer and promoter of this clean cooking aspect. I mean, I sat in a couple of different workshops in the past, and I mean, I in my childhood have experienced the impacts of this indoor household pollution. And I mean, humankind has developed so far, but in developing countries, we are still cooking on the Stone Age technology, 3-stone fire. Yeah, that technology needs to actually improve. And I'm already working on a small concept where we are working on an e-gasifier. This gasifier will not just use less wood or less solid fuel, because people will still cook no matter what technology you give them, whether it's solar and so on. They will still cook on the fire. You can't force everybody to cook on electric stove, for example. Yeah, and some cultural foods and cultural practices are such that people will always love to cook on a real fire rather than on a heater.
Exactly.
So, yeah, and yeah. So I thought we can work on a more energy efficient cook stove. So we developed a concept where we can not just reduce the 40% of the solid fuel consumption in the cooking process itself, but also we are doing better combustion, so less soot and tar and other emissions are produced. But equally, when they are cooking, and especially in rural and off-grid communities where they need electricity through thermoelectric generators, we can recover enough electricity in a battery pack, which can be sufficient for their lighting and mobile phone charging needs over the night. And obviously, more or less, people are cooking at least 2, if not 3 times a day. There is enough energy or thermal energy available during the cooking process, which can be recovered, and then it can be used through a battery pack for lighting and mobile phone charging. So we are working on a small clean cooking stove where we are addressing these issues.
Excellent, excellent. Thank you.
I think I'll give floor to other people so they can come in as well.
Yeah, it's open for everyone. If anyone wants to ask anything, I really enjoyed today's workshop. Very interesting and very ground level topic. Yeah, absolutely. I mean, we need to not just because another thing which I have seen, I'm sorry, my views are sometimes a little bit controversial. A lot of time when we talk about energy, people talk about electricity and electricity.
Controversial. Exactly, electricity. Nobody talks about heating, nobody talks about cooling and the rest. You are right.
Yeah. Absolutely. So, I mean, electricity is taken as a commodity for middle class or maybe more kind of upper class people. Yeah. The people who are sort of on the lower end, they don't see the electricity as a need for them. Obviously, it is a need for them, but it's not available to them. People have died 3, 4, 5 generations since the electricity is still there and nobody ever seen the light in their lifetime. How many more have to die without even seeing this light? And I don't care if this light is coming through solar or wind or hydro or biomass, as long as they see this in their lifetime, this is what we should be aiming for. Bringing everybody on board, leaving nobody behind, providing access to energy for everyone. It's a requirement. It's kind of a basic need for all economic development.
Excellent. I align with your philosophy. Brilliant.
Thank you.
Yeah. I really enjoy your last line in your previous discussion that we don't need investment, we need willingness. I really enjoy this sentence. Thank you so much, Dr. Muhammad Saeed. Thank you so much, Dr. Orginarora, for participating in these 2 workshops. And Dr. Simon is not here, but Dr. Ozigi was on his behalf. And Michael, Engineer Michael, were also participating in this workshop, and I think he's also here. I want to formally thank you everyone who are present in this workshop, the students, the presenter, the teachers, the researchers, everyone. Inshallah, next time we'll see each other again in some other workshops, in some other more interesting topics. I want to say thank you, everyone. God bless you. Thank you so much. See you again. Allah Hafiz.
Hey, Reksa, thank you so much. We just want to say a big thank you. Shall we turn on your cameras to make a picture of the screen? So at least you have people on your screen. So sorry, it's very late.
It's again electricity at my end, and my battery is just running low.
If people feel comfortable, so turn on your camera, and then maybe Hanan, you can make a screenshot. Yeah. Hey, smiling face, and big thank you, round of applause for Reksa as well. Sorry, why is mine not coming? Okay.
Thank you.
Thank you so much.
Thank you.
Thank you, everyone.
Hanan, have you made your screenshot when we are putting the clapping? So you have to do a double act, yeah? Thank you. Thank you.
Thank you.
Perfect. So thank you so much and stay blessed. I think we have got a workshop WhatsApp group. We just have put into the chat box. So anyone wanted to join for future opportunities, knowledge sharing, and maybe exploring some funding opportunities, please by all means join it.
Thank you.
Thank you.
Thank you very much.
Take care, everyone.
Bye-bye.
Bye-bye.
Okay.
Is there any WhatsApp numbers? Anybody wanted to leave WhatsApp number here? No. Okay, that's good. Thank you very much. Mohammed was really good.